Okay, let's talk about substitutes. A substitute is anything that replaces a H or replaces a hydrogen. That's going to be a substitute. And so, for example, we can have a and so, for example, this would be propane. And propane has all of these hydrogens surrounding the carbons in order to give the carbons the 4 bonds each that they need. Well, we could come in here and we could take off a hydrogen and we could put something else on here. I'm just going to put X for now. And that would be a substitute. And we would therefore have to name that substitute with proper nomenclature. And so the first substitute that I would like to talk about are alkyl groups. An alkyl group. Now, what an alkyl group effectively is it is an alkane minus a hydrogen. That's what an alkyl group basically is. So let's take a look at a couple of, we're going to just do simple alkyl groups. We're not going to get very complicated. And so if we take a look at CH4, well, that is methane. If we take off one of the H's, now it's free to bond to something else. We're going to use the letter R here. R just stands for something organic, if you will, another carbon, effectively. This becomes a methyl group. Or you could call it a methyl substitute, ready to be attached somewhere. If we go to 2 carbons, with all of their hydrogens around it, so C2H6, well, that would be ethane if we take off one of the hydrogens. It doesn't matter which one we take off, leaving it available to attach to something else, then leaving this carbon available to attach to something besides a hydrogen, then that is an ethyl group. So effectively, here's what you need to know about alkyl groups, is they are side chains or side branches off of the main chain. That's what an alkyl group is. So let me show you an example of an alkyl group in action. And so here is a butane group. So in this case, I haven't written them all, but the assumption is all of these are full of hydrogens. Well, let's say that I decided to take the hydrogen off right here. There was a hydrogen there, and I take it off, and I take a methyl group. So I took off the hydrogen off the methyl group. I take off the hydrogen here, and I move it on, and I attach it there. Okay, well, that is now a side chain. Here's my main chain. Here's my main chain in my organic compound. It's 4 carbons long. And then there's a side chain. Well, my 4 carbon long chain makes it a butane. But I also have a methyl group attached to my butane. And so this would actually be called 2-methyl butane, because I have a methyl on the second carbon from the end. And you can say, well, I can number it from this side over here. Or if I number it 1, 2, 3, 4, isn't that a 3-methyl butane? Well, no, not really, because I can't number from the left side. I have to number from the right side. Because if you go back to the lesson the other day, I said that you number the carbons from the end closest to a substitute. And so the end that is closest to a substitute in this case is the right end. So we're going to number 1, 2, 3, 4 from the right side. And so my methyl group is on carbon number 2. And so it's a 2-methylbutane. And so there's your first exposure to a substitute, 2-methylbutane. And so here's an example. Let's try this one. And so what would we call this thing? And so going back, remember our rules. The longest chain determines the root name. And so find the longest chain. Well, in this case, I drew it easy for you. I drew it straight. So there's our long chain right there. It's not always going to be straight, though. It doesn't have to be straight. And so there's our long chain. How many carbons are in this chain? We go 1, 2, 3, 4, 5, 6. So that's going to be a hex. All of the bonds between them are single bonds, so it's going to be a hexane. And then on carbon number 2, if you will, this is carbon number 2, because we're going to number left to right in this case, not right to left. We have a CH3, that's a methyl group. So this would be 2-methyl hexane. That would be what we'd call this. What would happen if I moved the methyl group to that carbon instead? Would it still be 2-methylhexane? No, in that case it would be 3-methylhexane. I moved it over one to the third carbon. It's now 3-methylhexane. What would happen if I took that group and I moved it over again? What if I move it over to this one right there? Would that now be 4-methylhexane? It would not be 4-methylhexane, because when I do that, I'm going to have to renumber this thing. Now I'm going to number from the right side of the compound. 1, 2, 3. It's back to a 3-methylhexane. It's the same as if it were over here. It's still 3-methylhexane, not 4-methylhexane. Let's do one more example. Okay, so here's an example. In this case, I left off all the dashes for the H's. That's okay. There's a whole bunch of dashes with H's everywhere, if you understand what I mean. But it's just going to get real sloppy if I start to draw all those H's in. So I am going to leave off the H's. I'm even going to leave off the bonds. You just need to understand that they are there and they are present. And so what is this thing? What do we call this thing? First, you need to identify the longest chain. And I told you it doesn't have to be straight. And so there's a couple ways you could define the longest chain here. But one way would be like this, right, like that. That'd be the longest chain. I could identify the longest chain this way. That would also be a longest chain. I could identify the longest chain this way as well. I could go this way. All of those are going to be basically the same thing. And it doesn't matter which one you do, you will get the same name as long as you are using the proper rules in naming the compounds. And so we're just going to use this chain right here as our long chain. And so now the question is, are we going to number from the left side, starting at carbon number 1 over here, or are we going to start with carbon number 1 over here? Let me actually do a different color in that case. Let me do blue in that case. And so number 1 here. If we do number 1 here, then this would be number 2, and that would be number 3, and that would be 4, and that would be 5, and this would be 6. If we number from the right side, we would have number 1, and then 2, and then 3, and then 4, and then 5, and then 6. Now, which one do we do? The groups determine this. Now, we have 3 side chains. All 3 of them are 1 carbon long, so they're methyls. They're all methyls. We have 3 methyl groups present in this organic compound. 3 methyl groups. Where are they? If we number the methyls using the red scheme, then there's a methyl on number 2, and there's a methyl on carbon number 3, and there's a methyl on carbon number 5. Okay, right, see, 2, 3, 5. That's where our carbons are located. If we number on the blue scheme, then we have a methyl on carbon number 2, right here. We also have a methyl on carbon number 4, and we have a methyl on carbon number 5. And so how do we do it? Well, here's how we do it. In the case of the red, we have 2, 3, 5. In the case of the blue, we have 2, 4, 5. We want to use the lowest numbers. So 2, 3 and 5 is lower than 2, 4, and 5. And so we're going to number with the red numbers. And so in this case, we're going to have 2, 3, 5, trimethyl hexane. That's going to be your name. So every time you have a group, you have to number it. If they're the same group, in this case they were all methyls, we can just keep the numbers together separated by commas, 2, 3, 5. The prefix tri tells us that there are 3 methyls and it must match the number of numbers that you have. There are 3 numbers indicating 3 groups. So we have trimethyl hexane, 2, 3, 5 trimethyl hexane. We are going to have plenty of practice in class on naming organic compounds. I want to give you the basics on the flipped video. So that's the end of this lesson.